first thing I want to say is that I thought the website was awesome. I could really see my students after they're finished with a problem or assignment, going back to one of my 3 student computers, going through some problems, finding some solutions, and presenting to the class. So I can see how I could use it come August. I'm excited about that. First thing, why I chose this problem is because anybody that taught the Pythagorean theorem realizes that you eventually run out of right triangles. Can everybody agree to that? You eventually just run out of right triangles. You only use the 3, 4, 5 one so many times, 6, 8, 10. Then they start to understand the concept and things get repetitive or redundant. So this problem, first thing I'm going to get into, all right, the grade level I felt was 8th grade level. The source was the website that we all got our problems from yesterday. All right, this was a little illustration of the problem. All right, so basically, summary of the problem. The purpose of the problem is to apply the Pythagorean theorem multiple times to find missing side lengths of an inscribed triangle inside of a rectangle. Then to determine if the inscribed triangle is a right triangle. The embedded mathematics in this problem. One, you had to know how to apply the Pythagorean theorem. That was huge. You have to be able to calculate square roots. And you would have to be able to identify Pythagorean triples to determine if a triangle is a right triangle or not. So has everybody got a brief idea of the content? All right. What Common Core state standard does this activity address? Really no need to read all these, but basically out of the 3 geometric standards, 3 of them dealt with the Pythagorean theorem. The main mathematical practices was to make sense of problems and persevere in solving them. All right. Now, to differentiate instruction, with this, I would basically allow some students to use a calculator because this problem only had 1 instance of a perfect square. Sometimes students struggle with non-perfect squares, rounding them to the nearest hundreds, things of that nature. Now, HOTS, that was your higher order thinking skills. Basically, with this problem, it asks you to analyze, also to apply acquired knowledge. So, like, once you already know the Pythagorean theorem, that wasn't enough for this problem. You had to analyze when you needed to use it, when you needed to calculate a hypotenuse, when you needed to calculate a leg. Question prompts for higher order thinking skills were what conclusions can you draw? And what is the relationship between, what's the relationship between the triangles, between the side lengths, and things of that nature. Now, strategies for struggling students. I oftentimes tell my students, well, prompt them to use what they do know in order to find out what they don't know. To have students list all the information they know about the Pythagorean theorem. And list all the uncertainties they have about the problem. Make a list of what you do know, what you don't know, and try to come up with the answer. All right, so we're going to get into the solution here. That was quick. Anybody have any questions, comments, concerns? Time filler, I need it.
You're doing fine.
All right.
Don't worry about that. As long as you're answering anything.
Now, basically the solution here. The procedures. First, you had to apply the Pythagorean theorem to calculate the side length of AB. Everybody see side length AB? And you had to realize, since this was a rectangle, that in the right-hand corner, that was a right angle. So the 2 5 units are your what? Your legs, and the other one will be your what? Hypotenuse. So you can flip over to the back. So we came to the conclusion that this side length was the square root of 49, which is 7.100. Then we had to calculate the side length for CB using the Pythagorean theorem again. So you end up getting 14 squared plus 7 squared gave you the square root of 245. So this one came out to be what? I think it's on your paper. 15.6. So then from there, they gave you this side length. So you also had to know about Pythagorean triples. So you had to realize that 15.6 was the longest side. So that will get what variable? C. So you apply the Pythagorean triple formula. C squared, right now is unknown to A squared plus B squared. But we found out that 243 is not equal to 49.98 plus 225, resulting into no. The inscribed triangle is not a right triangle. Y'all been a wonderful audience. I appreciate you.
I want to go back just a second, if
Yes.
you will, to something. Go back to your slide where it's sort of got the pre-knowledge embedded math one that. All right, so this is the pre-knowledge. This is what your students would have to know before you began this. Can you see yourself giving this, like maybe before any of this, maybe giving this picture and, you know, saying, do you think that if you take a rectangle and you split it like this, do you think that's the right triangle? They're going to think it looks like one, right?
Yeah.
And just present this first and let them give you their idea and why. And most of them, their reasoning is they're going to say it looks like one, or if the rest of them are, that one is, you know, and not knowing any of that. And then after you do this, then present this again and ask anybody, do they want to change their mind about this, you know, work it again. But I can see, I think this is a good problem. And by the way, I appreciate you did a PowerPoint. That was very nice. And, but I can see people that don't know this at all before you ever start saying, what do you think? And then after they know a little bit about the Pythagorean theorem, so that when I have to teach this to the people in the 292, the people that are going to be out there and teachers, you do know that on the, just offside about the Pythagorean theorem, you do know about the Wizard of Oz and Pythagorean theorem, don't you? On the Wizard of Oz, I have to show it to y'all somehow. I got this up there, yeah. But when the scarecrow gets his brain, he says,